Let's continue with a new chapter, chapter 5.1. Normal distribution. This concept is very important, and we'll see it frequently for the next couple of chapters. It is important to keep in mind that the area under the curve is 1. Similarly to the sum of all probabilities, we're essentially working with probabilities in another perspective. So recall, in order for something to be a probability, 1, the sum of all values needs to equal 1, and every probability needs to be between 0 and 1. No negatives, nothing bigger than 1. Well, we're going to take another look at probabilities and consider them as a bell-shaped curve, where the sum of 1 is within the curve. Let's look at these definitions. A normal distribution is a continuous probability distribution for a random variable x. The graph of a normal distribution is called the normal curve. A normal distribution has these properties. 1. The mean, median, and mode are equal. 2. The normal curve is bell-shaped and is symmetric about the mean. 3. The total area under the normal curve is equal to 1. 4. The normal curve approaches but never touches the x-axis as it extends further and further away from the mean. 5. Between mean minus sigma and mu plus sigma, the center of the curve, the graph curves downward. The points at which the curve changes from curving upward to curving downward are called inflection points. So rule 3 says that this whole sum of this whole curve is equal to 1. And it also pointed out that the mean goes through the middle and it's symmetric, meaning what's left of it is the same, a mirror image, as what's right of the mean. We also said that when it's 1 standard deviation away, we have a special point called an inflection point. And that's just when the direction of it changes. So here it changes from going upward to kind of going downward. The key points to remember are that it's symmetric, meaning a mirror image from the mean, the average, mu, and the sum of it is 1. That's what will come into play pretty often. Let's do an example. Based on the image, we want to answer these questions. A, which normal curve has greater mean, and why? So we see that A has a greater mean because we see that the mean is 15 versus this one has a mean of about 12. And B, which curve has a greater standard deviation and why? So the one that would have a greater standard deviation would be B because it's more spread out. Versus this one, it's a lot more narrow. So therefore there's a bigger difference between each standard deviation in the curve. New definition. The normal distribution where the mean is 0 and a standard deviation is of 1, let me underline that because we'll see that pretty often, is called the standard normal distribution. The horizontal scale of the graph of the standard normal distribution corresponds to z-scores. So these numbers here are z-scores. And if we're going based on z-scores, then 0 is our mean because there's no difference within the z-scores. Once we go right, we have positive z-scores, and when we go left, we have negative z-scores. And as you can see, there's kind of a limit as to what your z-score can be, even though theoretically there isn't, because according to our definition above, these endpoints never touch your line. They're technically going on to infinity. This is what's called the standard normal distribution. And whenever you see standard normal, know that it implies that your mean, your average is 0, and that your standard deviation is 1. Meaning the difference from the mean to 1 standard deviation is 1. Notice that the number of standard deviations doesn't go past about 3.5. At 0, we have the mean, and negative values of standard deviation are to the left, and to the right are the mean positive standard deviations. The positive and negative values just give us a direction from the mean. Properties of the standard normal distribution. The cumulative area is close to 0 for the z-scores to z equals negative 3.5. I'm sorry, 3.49. So your area is close to 0 when it gets close to this point, about 3.49. B, the cumulative area increases as the z-scores increase. And that makes sense. As you get a higher z-score, your area, the value of 1 will also increase. C, the cumulative area of z equals 0 is half. That would make sense because that would be half of 1. And D, the cumulative area is close to 1 for z-scores that are close to z equals 3.49. So that would mean the other end of the curve, which means you've gone all over it, which is equal to 1. Moving on. Here I have some notes for calculator use. This will help you find the area under the curve, which will tell you the probability. Now again, like I mentioned in the module introduction, we're essentially doing some calculus here without having to actually need the use of calculus. We're using some clever techniques so that we can see exactly, if we're looking at a curve, what is the area corresponding to this part of the graph, or whatever part of the graph you're looking for. There's calculator instructions, and there's Excel instructions. So let me just point them out. You're going to go to press the second button, then bars. You want to choose normal CDF. Press enter, and you're going to enter information in these 4 pieces. You want the lower bound, the higher bound, the mean, and the standard deviation. And what I mean by that is when you have a curve, you're going to be asked a value to work within. Say you're looking for this shaded region. Your lower bound would be negative infinity because it goes on forever, and your upper bound would be the number you want to stop at, say x. We don't have a negative infinity button, so we can just put a really negative big number. So negative 10,000, 100,000, or negative 999,000, I don't know. A really big number. And your higher bound is wherever you want to stop. You can manipulate your lower bound and your higher bound however you like. Your mean, that's either given or you have to find it. Same for your standard deviation. And there's more instructions written below. Excel, you enter your equal sign and you get equal norm dot dist, and you're going to enter the information pretty similarly. What's cool about Excel is it tells you how you want to input things. You first want to enter the value you want to work with. So if you're working with some bell-shaped curve, say we have some value we want to find. The value is that first number, that stopping point. Then you want to enter the mean, your standard deviation, and then you want to choose either true or false. You enter true if you want all the area from the left at 0 to your stopping point. And you enter false when you want only that single point. What's the probability of only getting that single value? Note, for the following problems, we're not given the mean and neither the standard deviation. Thus, we're working with the standard normal curve, which is the perfect curve, and we know from that our mean is 0 and our standard deviation is 1. Since that's the piece of information we'll need, let's just point that out, that our mean will be 0 and our standard deviation will be 1. Example, for these problems, I'll include an answer. You can make sure that you can use your calculator or Excel, but I think it's super important that you're comfortable with drawing your bell-shaped curve. That will keep you from doing silly mistakes because I feel like the hardest part of this course is reading the problem and taking in the information. So let's go ahead and work these problems out. Your answers are written. Make sure you know how to punch them into Excel or your calculator. Let's take a look at one. Find the cumulative area that corresponds to a z-score of 1.15. All right, let's begin by drawing our bell-shaped curve. All right, since it wants a cumulative area, our mean is at 0, and we're looking for a z-score of 1.15. I don't know where that is, but I know it's to the right of the mean. So I want to find all the shaded area from there to the left. All right, and we're going to enter this in my calculator. If you do use your calculator as normal CDF, your lower bound is negative infinity, so we put a negative big number. You can put negative 9s, a bunch of 9s if you want. Doesn't matter. Just a really big number. And then we want to mark where we stop. We stopped at 1.15. And then we want to enter our mean and our standard deviation. Because we're told that standard normal, our mean is 0, and our standard deviation is 1. For Excel, same idea. But we first want to enter our starting value, the value we want to stop at. So it's 1.15. Our mean is 0. Our standard deviation is 1. And we're working from negative infinity to your stopping point. So therefore, we enter true. Now you should get an answer that's something like this. And for Excel, yes, you do just punch an equal sign and that. What's cool about Excel, like I said, is that it tells you, if you forget the order of things, it tells you how to enter them. 2. Find the cumulative area that corresponds to a z-score of negative 0.10, negative 0.24. All right, so let's draw our bell-shaped curve. We know at the center, at the height of our bell shape, we have a mean of 0. And to the left, I have my negative numbers, and to the right, I have my positive. The number I'm working with this time is a z-score of negative 0.24. So that's a really small z-score, right? Well, actually, not so much. If this is 0, and it's between negative 1 and negative 0 and 0. So we have this value here, negative 0.24. We want to find the area from negative infinity to that stopping point. All right, here you have your calculations, and there is our answer. Let's continue with 3. Find the area under the standard normal curve to the right of z equals 1.06. All right, let's draw a bell-shaped curve. And notice I highlighted that a different color. This is what I mean where it can get tricky. We have our bell-shaped curve. Our center is 0. Now I want a z where I'm going to the right of 1.06. So this is what I'm looking at. Now all the commands are set to read from 0 to infinity. So they're used to looking for this piece. But that's not what we want. We actually want the complement. We want this side. So we can set it up as though we want the left side. So we set that up to be either using Excel or a calculator. You find your answer. You do 1 minus whatever answer this is. And that will give you your desired value to the right. Now let's focus so you can type it in. In your calculator, You can type it in one shot and do 1 minus and then your typical command. Same thing for Excel. When you go into calculations, you have to put the equal sign first. So you put equal sign and then 1 minus and then your normal command. So that gives us the complement. Remember, the complement gives you the other side. So use complement rules. That's one word. To find the right side. That's why it's so important to take a moment to draw it out, because the wording can be slightly tricky. We can get into just thinking that's always from left to right, where we can also have from right to left. Let's take a look at another question. Find the area under the shadow normal curve between, so we have between 1.5 and 1.25. All right, so let's draw a bell-shaped curve. And notice I'm no artist, but I still draw this so it helps me out. So I have 1.5 and 1.25. Negative 1.5. I have negative 1.5 and positive 1.25. And I want the area between. So this is what I want. Now keep in mind that our commands only work from negative infinity to a stopping point. So we're going to have to be clever about this. So why don't we do it this way? Why don't we first find the area from the larger point to the end of negative infinity, and then let's subtract the value from the smaller end. And left over, we'll have our desired area in the middle. I'm sure that shading isn't helpful. So if you want the area between, you want to start with your larger area minus your smaller area, and that will give you that middle portion. Now, if you're using Excel, you do have to type each command separately, but you can be a bit more careful with it. So notice how for Excel, we have our larger one, and then we're subtracting our smaller one. And you can do that in one shot to get your answer. When using your calculator, you can be a bit more careful. If you want that middle portion, then your lower bound is negative 1.5 and your upper bound is 1.25. So you can manipulate your calculator so you can do that in one shot. Or you can do both. You can do it like Excel and do the highest minus the smallest. They'll still produce that answer of 0.8275. All right, this section is really important. I think drawing it makes it easier to work with. I did provide some videos that I think are explain how this works and how you use your functions in Excel or your calculator or whatever you're working with. So check those out.